Okay, good morning, Year 11. This is your lesson on vectors for today. We're going to be looking at proof. But before we start that, 10 questions just to get us going. So 10 questions, answers on the next one. So obviously pause, have a go, see how you get on. Okay, so there are the answers. Obviously go through, check what you've done. Any questions, just put them in the chat. I'm more than happy to help you and answer any problems there, but very similar to the ones we did last time. Okay, so on to today's lesson. Now we are going to be looking at proving vectors are parallel and are collinear. Now collinear basically means you've got 3 points and they all form a straight line. Okay, so we'll come to that, but we need to be able to do parallel before we do collinear. So just a quick question there on the board, just to get us on the screen, should I say, just to get us started. To have a quick go at that, I'm going to do the answers virtually straight away, so you might want to pause. But this is the type of question that a few people were having problems on with the work from last lesson. So basically, because it's a irregular hexagon, these are all equilateral triangles, although they don't look particularly equilateral. They are because there's 6 of them. We've got 360 degrees, obviously shared between 6. So find in terms A the vector AD. So A is there, D is there. Well, basically it's straight down there, and that is minus 2A. Okay, so it's basically because this distance here is the same as this distance, equilateral triangles, it's basically a straight line. So that's the first one. Next one, we want AB. Well, A to B, hopefully we're all okay with that. That's just going to be skipping on a slide, that's helpful. Minus A plus B, making sure we've got them going the right way. So we're basically going to go down and then up. And then AF, well, AF is this one over here. And because they're all equilateral triangles, A to F is basically the same as B, except you're going the wrong way, so minus B. Okay, so some fairly straightforward vector questions there just to get the brains going. Now, last Wednesday's lesson, did we do a live lesson? It was a live lesson. This was one of the questions we did just to finish off, or some people got onto. So I thought we'd just have a quick recap of what we need to do here. Now we need to show that OP is basically a fifth of 2A plus 3B. Well, OP is basically down there and up there, or you could actually go up there and down there. So let's actually work out what we've got. I'll tell you what, we're going to go that way round. Okay, so we're going to go up there and down there. Now we know that AP to BP is 3 to 2. And remember I said just put them as fractions. So it's 3/5, 2/5. Okay, I've got that. I'm going to have to know what AB is. So I'm actually going to write it out. So AB is basically equal from there to there, but I've got to go minus A plus B. So now I know that bit, I can work out that OP is going to be A. So I'm going to go up there, and then I need 3/5 of this. So plus 3/5, and notice I'm going the right way down it, A to B, 3/5 of minus A plus B. Multiply it out, so I've got A minus 3/5 A plus 3/5 B. Okay, and then that's going to give me 2/5 A plus 3/5 B. Not quite how the answer wanted it, but we can factorise. We can take a fifth out, which therefore gives me 2A plus 3B. Okay, so our OP is equal to that, and you can clearly see the steps we've used there to work round. You could put an extra line in here where we've done O to A plus A to P, just so everyone knows exactly what we're doing. Okay, so that's kind of what we were doing on Wednesday. Now, I don't know why we need another slide, sorry. Show vectors are equal. You might want to actually have a go at this question yourself. So obviously pause, if not I'm going straight onto it. So, it's an exam question from March 2013. First thing, express AB in terms of A and B. Well, let's go for it. So AB, let's have a look at the diagram. So that's from there to there. We don't know, we can't use that. We don't know what it is at the moment, but we can go around that way. We can't go that way because we don't know what this side is. So it's basically going to be the wrong way down 3A plus your 6B. Okay, so that's the first bit sorted. Now, what we have to do, X is the point on AB. Yep. AX and XB is 1 to 2. And then we're told BY, oh, that's on the diagram anyway. So 1 to 2, so basically a third and 2/3. Prove that OX is equal to 2/5 of OY. Well, let's do OX to start with. So OX, clearly stating what I'm doing. So O to X, we've just worked out AB, which is quite handy. So we're going to be using this because basically OX is going to be OA plus a third of AX. So I think I'll probably run out of room here. But anyway, so we're going the right way down. So we've got 3A and then we need a third of what we calculated earlier. So multiply and tidy that all up, and we end up with 2A plus 2B. Okay, so expand this, gives us a minus A, so 2A, take away A, gives us 2A, and then a third times a 6 is 2B. Okay, so we've got that. Now let's work out what 2/5 of OY is. Or 2/5 of OY is basically going to be, and I'm just going to write it out so you can see, 2/5 of OY. Well, I can't go straight up there, so I'm going to go up there. So I'm basically going to do OB plus BY. So OB 6B plus 5A minus B. Okay, so again, I could have put a line in there, 2/5 brackets OB plus BY. Have a bit of a tidy up, so that gives us 2/5 of 5A plus 5B. Let's multiply that out, that gives us 2A plus 2B. Okay, and then basically you need a little statement saying that you've proved it. Okay, so basically OX, therefore OX equals 2/5 of OY. Just so everyone can see that you've done what you set out to do. Okay, so that's showing vectors are equal. Now, on to, I don't know why I've done that, parallel. Okay, now, you can see these lines are parallel. One's twice as long as the other. So the 2A, that's a multiple of that one, double the length. This one here, we've got A plus 2B and 2A plus 4B. So this one's twice as long. Still parallel. Okay, and this one we've got A going up there and minus 3/2A going that way. That's still parallel. Okay, you're going the wrong way down this one, hence why it's negative, but actually this is 1.5 times longer than this one. Sorry, you can't see it. I'm just waving my pen around, you can't even see it. Sorry, this one's 1.5 times longer than that one. So they are parallel. Okay, vectors are parallel if one is a multiple of another, which is kind of what I'm getting at there. Times 2, that one was times 2, this one was times minus 3/2 or 1.5. Okay, still parallel even though it's going the other way. So that's what we need to bear in mind when we get onto the questions. So you might want to pause it. We're just going to see which ones are parallel and which ones are not. Okay, so first one, not parallel, okay, because the B's double but the A hasn't. If it was 2A plus 2B, it would be parallel. This one, they've both been times by 3. So, yep, absolutely parallel. Now this one, okay, they've both gone from being positive to negative, and they've both been multiplied by 3. So actually, they are parallel. And then the last one, let's have a think. They've been multiplied by -1. Okay, so although the signs have swapped, they are actually parallel. Okay, because one was negative and now it's positive, and one was the other way around. Okay, so those last 3 are parallel. So the questions you're likely to get with that, which I'm sure you're all keen to see, is something like this. Show that 2 vectors are parallel. So now we've got questions like we were doing on Wednesday, but we've got to do that final step and show that they're parallel. So x is a midpoint AB. AB, x, oh no, is a point on AB. I was going to say it doesn't look like a midpoint. AX and XB. So we've got 3 to 1, 3/4, and 1/4. M is a midpoint of BC. Okay, so we've got 1/2 and 1/2. Show that XM is parallel to OC. Okay, so we've got a line going from O to C and a line going from X to M. We've got to show they're parallel. Right, well, let's work out what OC is to start with. So OC, we can get to OC by doing OB plus BC, which is basically B plus A. Okay, fairly straightforward because obviously it's a parallelogram. Because it's oh yes, it does tell you they're parallelograms. We've got these lines on here. Oh no. Okay, it is a parallelogram. So we've done OC. Now we need to work out XM. I think somewhere in the question it would state it's a parallelogram. XM, so from there to there. So basically we need to have 1/4 of AB, which we can work out, plus 1/2 of BC. So basically we want 1/4 of that one, the bottom quarter there, and then 1/2 of BC. So we need 1/4 of AB. Well, AB is -A plus B, and then this one is just 1/2 of A, which gives us so that gives us -1/4 A, so that's 1/4 A plus 1/4 B. Okay, so we've been tasked to see whether they are parallel. Well, they are parallel. If you look, they are a multiple of each other. So if we did 4 lots of XM is equal to OC, therefore they're parallel. Okay, always need to state it at the end, just so you can really clear what you're doing. You're showing that it's a multiple. If we times this by 4, we do get, times XM by 4, we do get OC. Okay, so that's how you show that they are parallel. And that is the nice typed out version, showing that they're actually parallel. And in fact, factorized at the end here, taking 1/4 out rather than just written it out in a different way. I've said that 4XM was equal to OC. They've actually just factorized it to show it's a factor. Okay, just a different way of showing it. Right, so that's parallel. Okay, we can just test our understanding, or your understanding. So have a quick go at that question. Pause it, and then we'll have a look. Just check you're okay with it. Okay, so A to B, hopefully we're all good with that. -3A plus 3B. And then we've got point P. So we've got that ratio 2 to 3, so 2/5 and 3/5 is parallel to O. Show that OP is parallel to the vector AB. Well, all you need to do is work out what OP is, and show it's parallel. Okay, that's actually the mark scheme there. Probably a good idea if I work through it as well. So OP is equal to 2A plus, what do we do? So we've got 2/5 and 3/5. So we've got 2/5 of AB. Well, that's minus A plus 3B. Kind of what they're going on. So yeah, they do this bit here. Okay. Tidy that up a bit. So that's going to give us minus. Oh, I've put the plus now. So we've expanded the brackets. Let's have a bit of a tidy up. So that gives us 6/5 of A plus 6/5 of B. They're the same, so actually they are parallel because we can then factorise. Let's do it the same way that they've done it. Okay, so actually you can see they are parallel because one is a multiple of the other. Okay, so that's parallel. One other thing you need to be able to do with your proof is show that they are on a straight line, or collinear is the correct mathematical term. So, oops, our 3 points, we know they're on a straight line, so if A to B and A to C are parallel, they must be on a straight line because they're going through the same point and they're parallel. Okay, or you could use any point. You could do A to B and B to C and show that they are they're parallel. That's absolutely fine because they'd both be going through that point. Okay, obviously that bottom diagram, they're not parallel. So what does it look like in a question? There you go. Okay, so have a go at that. I will go over it in a minute. So, short minute, I know, but find BP. Well, that's going to be hopefully fairly straightforward. So BP, what have we got? We've got AN. So we haven't even got a ratio here. They're saying A to N is 2B, N to P is B. Okay. B is the midpoint. So right, actually, that little bit there is A. And M is the midpoint. Right, that's halfway on there. So we need to do B to P. So we're going to have to go minus 3B. And as I said, it doesn't really matter which way round you write it. You could write A minus 3B. So that's the first bit. Now we need to show that NMC is a straight line. So let's do N to M. So if we do N to M, okay, it's basically going to be NP plus a half of BP, which we've already worked out quite handily. So NP is B plus a half minus 3B plus A. Have a little tidy up and we should end up with minus a half B plus a half A. Okay, well that doesn't really help us at all at the moment, so we need to then work out, let's do NC. NC, oh right, okay, well that's going to be fairly straightforward because that's from there to there, but we basically know that's minus 2B plus 2A. Okay, so they are a multiple of each other, okay, and they both go through the same point, so therefore they're on a straight line. Okay, so basically 4 lots of NM, or you could factorise them both, it doesn't really matter, is equal to NC, so they're parallel, and N is a common point. And you do need to make those statements at the end just to show that you know what you're doing and show what you've proved. Okay, so they're the two types of proof you're going to get, either parallel or whether they're on a straight line. And it's all about these sort of journeys around the shape in terms of your vectors. Now, for today's lesson, I've already given you the worksheet. So the worksheet you had on Wednesday, it's still attached to the Wednesday task. You need to do the last exercise. Okay, so the last exercise, if you've got as far as that. If not, obviously carry on, do the exercise in the middle. There's a one on the middle sheet, and I'll share all the answers with you on Tuesday. Okay, obviously any questions, please do put in the chat. I'm just showing you there how they've written out the proof, or how Dr. Frost, I've pinched his slides, has used the proof. Okay, so that's today's lesson. Obviously any questions, put them in the chat. Likewise, once you're done, if you could please put in your learning review, just let me know how you've got on, and that will allow me to plan tomorrow's lesson. Thank you very much.